Hi, in this video we will learn about a new class of functions that can be integrated through integration by parts. Let me just quickly recall the integration by parts formula. Integral of u dv is equal to uv minus integral of v du. Okay, let's start with the first example. Here I have an integral of x times cosine x. Well, there are two functions, so either I put u to be x or cosine x. Well, the good choice here would be setting u to be x and dv to be the rest. One reason for that is that if you look at the right hand side of this integration by parts formula, we are going to use derivative of u. So if the derivative of u gets simpler function, that is a sign that we are choosing right u. Here, u, if I choose x, the derivative is 1. That's only just one simple choice or hint that we are going on the right way. But the only way to see if we are right or not is to do the integration by parts and see if it works or not. So we are choosing u to be x and dv to be cosine x dx. As a result, I have to find what is du. Du is the derivative of x, which is 1 times dx. So I just write dx. And I can find v by integrating dv. And that is, what is the integral of cosine x? It is sine x. Now, let me apply the IBP here. So x cosine x dx is going to be x times sine x u times v minus integral of, so that was u times v. Now integral of v times du, which is just sine x times dx. Well, right away you notice here that the integral on the right hand side is just a simple integral. What is the integral of sine x? This is from the table of integration, and you know that it is negative cosine x and then plus c. So that is what we find for integral of x times cosine x. Let's do another example. Here I have integral of 4x minus 1 times sine of 5x dx. Again, here I have several choices for u and dv, but remember we choose u to be a function whose derivative is simpler. Here I have 4x minus 1, so the derivative of 4x minus 1 is 4. That's a sign that we are on the good right track, though I have to complete IBP and see if this is good choice or not. So I'm setting u to be 4x minus 1 and dv to be sine of 5x dx. From there I need to find du, which is going to be derivative of 4x minus 1, which is only 4 times dx, and then I need to find what is v, which is integral of sine of 5x dx, which will give me, well, you need to do u substitution here, but in general it's good to know that the integral of sine of mx, if m is not 0 dx, is 1 over m, negative 1 over n cosine of mx. But this is a result of u substitution. So here, then back to our IBP preparation, I have negative 1 over 5 cosine of 5x. I have all the components I need to apply IBP. So integral 4x minus 1 sine of 5x equals to u times v. So that is 4x minus 1 times negative 1 over 5 cosine of 5x minus integral of v times du. So it is v is negative 5 over cosine of 5x times 4 dx. Okay, and then that is just, well, let me just simplify that. Well, not simplifying, that's not a, and I can take the constant part outside, that's plus 1 over 5 integral of cosine mx dx. Again, m is not 0. By substitution, you can find that that's 1 over m sine of mx. So I have 1 over 5 as constant outside. Integral of cosine of 5x dx. I actually have 4 over 5. There's a constant also here. I can take it out. So integral of cosine 5x is 1 over 5 sine of 5x. And then, well, you can simplify, or I will leave it as is. Okay, let's do one more example here. Integral of x squared minus 3x plus 5 cosine of 2x. As I did, so you hopefully seeing that what's going on when you have a polynomial time cosine of mx or sine of mx, you take u to be the polynomial and the rest as dv. So here IBP, integration by parts, u is x squared minus 3x plus 5, and dv is cosine of 2x dx. From that we can conclude that, well, du is going to be 2x minus 3 times dx, the derivative of x squared minus 3x plus 5 times dx, and v is integral of cosine 2x dx, well, which is, by what we recall up there, is 1 over 2 sine of 2x. Very nice. Now I want to apply IBP, integral of x squared minus 3x plus 5 cosine of 2x dx. Then this is u times v, which is x squared minus 3x plus 5 times a half of sine of 2x minus integral of v du. So integral of 2x minus 3 times half of sine of 2x dx. And now when I look at the last term there, what I notice is that, oh my, this is not an integral that I can find from the table. Actually, it is a polynomial times sine of 2x, which we just learned that these can be done by IBP. Does that mean that we didn't do the right choice for u and v? If you check the original integral, we had a polynomial of degree 2 times cosine. Now I turned it to an integral with polynomial degree 1 times sine 2x. So it is simplified. And if we continue doing our IBP another time, so this is the second IBP, IBP, the second one, then we get, well, I will choose this one to be my u. U is the polynomial 2x minus 3 over 2. The rest is dv, sine 2x dx. As a result of that, we have du equals to, well, 2x over 2, which is just x, minus 3 over 2, the derivative is 1 dx, and v is integral of sine 2x dx, which will be negative 1 over 2 cosine of 2x. As I said before, you can do that part by just doing the substitution. Okay, let me take this put up there. That's our second IBP, integration by part. The first one we did it here. Now we are doing it another time. So x squared minus 3x plus 5 over 2 sine of 2x. We won't touch that part. But this one here, we are going to do IBP the second time. So this will be u dv. Remember these steps, u dv, which is 2x minus 3 over, okay, there's another minus sign there, over 4 cosine of 2x minus integral of v du, which is negative half of cosine 2x dx. Okay, now you see the last step here. This is now an easy integral to do. This, the whole integral will be negative 1 over 4 sine of 2x. There is a negative sign out there. There's another negative sign out there. So we all together going to have x squared minus 3x plus 5 over 2 sine of 2x plus 2x minus 3 over 4 cosine of 2x. I'm multiplying that minus sign inside. There is 1 minus 2 minus 3 minus, so the whole thing will be negative 1 over 4 sine of 2x, and then here I need to put that plus c. So in general, the class that we were working with is the functions of integrals of the form integral of a polynomial, then sine of mx dx can be found or can be integrated, those functions, by setting u to be polynomial and dv to be sine of mx, and repeating this idea until we get a polynomial which is just constant. The other class, the similar class, is polynomial times cosine of mx dx, and this can be found by setting u to be that polynomial and dv to be cosine of mx. And the number of times that you need to use integration by parts is the degree of that polynomial.